All right, thanks for joining. If you're tuning in, you're looking for 5.08, the product rule of derivatives, right? Sorry for my sloppy handwriting. The product rule, what is it? How do we do it? When is it used, right? So the product rule defined is if we have some function y, and let's call it u times v, right, of two functions being multiplied together, two distinct functions. We can't just take the derivative of each function and multiply them. We have to use this product rule. We could prove that, but essentially what's going to happen here is we take that first function, we take the derivative of u, which is u prime, we multiply it by the original v. Then, pardon, we're not going to multiply, we're going to add the original function u times the derivative v prime. So we can see that we actually have four things that we have to put together. So we started with just u and v. In order to get the derivative, we had to find u prime v plus u v prime. That's our formula for using the product rule. Now we have this kind of strategy where we set up u, v, u prime, v prime, and we just kind of go in a cross order there. But let's just kind of review one of these. One would be, let's say we have a function y equals 2x. Maybe that was a weird x. 2x squared cosine of x. Okay, we have two distinct functions here. Now you might be looking at maybe the 2 is a function. Well, the 2x squared is an entire function, right? This whole thing I'm going to call u, and this cosine x here I'm going to call v. Those are two distinct things that I can find the derivative of. So what we're going to do is we're just going to notate those down here: u, v, u prime, v prime. So u is 2x squared. V is cosine of x. Now I got to remember my derivative rules. Well, for 2x squared, I'm going to use a power rule. Bring the 2 down out front and multiply it 4. Keep the x, and then subtract 1 from my power. 2 becomes a 1. So I could really put a 1 there, but I'm just going to leave it as 4x. It's the same thing. And cosine of x, remember that cosine, when you take the derivative, is negative sine x. It would be so nice if just cosine turned into sine, but it's negative sine. So these are our functions and derivatives. So in order to find y prime, the derivative of this original function, we're going to use this formula. So u prime. So we might start down in this corner and go to v. So u prime times v, so 4x. And I'm going to use parentheses to group and show multiplication times cosine of x. You should also use parentheses to group and show multiplication in the product rule. I'm going to add that to u times v prime. So parentheses 2x squared times v prime negative sine x. You can notice that if I didn't have parentheses around sine x, it would look like subtraction, which is not good. We want to multiply those two things together. Now, technically, this is it. This is your derivative. But we should note that we can simplify this a little bit more and just combine some things together, like 4x times cos x. Since those are each kind of one term, I'm just going to write that as 4x cos x. I can just put those two things together. And then here I have 2x times a negative. Think about that as a negative 1. That's going to turn into negative 2x squared sine x, right? Think about 2 times negative 1. There's where that negative 2 comes from. So instead of putting plus a negative, I just put subtraction. So both of these correct, but I would say this second one is correcter, is better. It's more simplified, put together. This would be the product rule. So identifying what u and v are, what the two functions are, and then being able to put those in the correct order and then simplify if you need to. Okay, that is the product rule. If you wanted to talk about like one more example, let's do one more example. Why not? We're here. Let's say, instead of saying y this time, sorry, I got the hiccups all of a sudden. Let's say f of x, and we'll try another one here. We'll do 4x plus 1, put that in parentheses, times, I don't know, let's get crazy. Sine of x minus 3. Clearly you can see that we have two functions being multiplied together. So what I would do here is I would annotate u and v. I know that I need to use a product rule because I have two distinct functions being multiplied. And then I would annotate my u, my v, my u prime, and v prime. So my u is going to be 4x plus 1. If I take the derivative of that, that's just 4 plus 0. And then v is going to be sine x minus 3. What's the derivative of sine? Cosine. What's the derivative of -3? 0. So here are my values. So when I find f prime of x, I just have to once again make sure I put them in this order. U prime to v. So 4 times sine of x minus 3. And then remember, we're adding the product of u and v prime. So we're going to go back up to u, which is 4x plus 1. I'm going to use parentheses again. Times v prime, which is cosine of x. Okay. Now you could put some things together here again, and we notice that some things that I could, in fact, put together. I see that I have 4 times sine of x and -3. I could distribute there, and I could call this 4 sine x minus 12. And then I'm going to add to that 4x plus 1. Well, that's all multiplied by cosine of x. So I can call this, 4x cosine x. 1 times cosine is just cosine x. And I can kind of add those two things together there, and I can add all of these things together. I don't think there would be any common terms here to kind of put together. So this would really just be our answer here. It's sloppy, it's messy, because I'm writing on a computer. You're going to be much more organized when you submit your own work. So just remember to make these annotations with your charts, right? Figure out which one is U and V, and then just make sure you do your derivatives properly and you just put it in the correct order according to this really super important and really nice formula. Okay.